Great, good morning, and welcome to the continuation of the discussion of Visual Studio 7 and the Web Services Platform. I'm John Montgomery. I'm the Group Product Manager for the Web Services Platform. On the next slide, you'll see that I am going to be talking today. Oh, sorry, wrong one. Questions and availability. I want to reiterate some of the things that came up in the last presentation. If you have questions, email them to count@microsoft.com. Submit them via the chat line. And any other questions that we can't get to today, we'll deal with offline. As Dave Lazar mentioned in the last presentation, he talked about the availability of material. Anyway, so things I'll be talking about today: web services, the strategic vision for us of delivering software as a service, how we're going to be doing that, the web services platform, Active Server Pages Plus, the services framework, and the common language runtime that enables all of this to work. Fundamentally, Microsoft is committed to delivering software as a service. We're building web services into every aspect of the next generation of our platform. Many of you have probably heard the code names of this platform. We'll be announcing the name of the platform at Forum 2000 in a few days. For now, we're just calling it the Web Services Platform. What it's enabling is a loosely coupled, message-oriented, asynchronous way of computing that is more scalable, more reliable, and easier to develop for than building COM components today. In order to enable this, we're advancing COM, Active Server Pages, and our programming frameworks and tools to make it easy for you guys to build applications. On the next slide, you'll see a very simplified version of how we build applications today. Today, when you build an application, you program against a bunch of local services: the file system, user interface, data access APIs, things like that. It's a very rich way of building applications. It's very tools friendly. But there's some limitations to it. In particular, things like deployment, where you have to touch the registry in 32 places to deploy an application. Security, manageability, even to some extent just the infrastructure of writing COM components isn't as easy as it should be. Since last fall at the Internet Strategy Day, where Paul Maritz and Steve Ballmer began talking about the Web Services Platform, we've been talking about delivering software as a service. Well, today, the way that's done is you take a rich application and you project its user interface only out using a browser over the Internet. The alternatives to doing that are large distributed object systems like Corba or DCOM. But fundamentally, those don't scale to the Internet. There are inherent limitations in the technology and the way they're built that makes it more difficult to actually do that with today's technologies. On the next slide, you'll see how we are beginning to move toward web services. One example of those services is Microsoft Passport, an authentication service. Most of you probably know it just from logging into MS Investor or Hotmail. But in reality, Passport is a very sophisticated authentication application. The vision of delivering software as a service is one where you could actually take the capabilities of a service like Passport and combine it with local services to build one application. The advantage of this for the developer is obviously they don't have to build their own, say, authentication infrastructure. The advantage for the person operating the application is that the actual operations of that portion of the application is offloaded onto a third party, for example, who is then responsible for making sure that the application is up and running at all times. The advantage for the end user, in the case of something like Passport, is that they get a single sign-on to not just your application, but to a bunch of other applications. The same could be said for, say, if you wanted to use a language translation service in your application. Rather than needing to send out new COM components every time you added a language or increased the vocabulary, if you're calling a web service, the web service will be responsible for maintaining that and dynamically updating the dictionary for you. You just make your calls into it and treat it as though it were an API. In order to make this possible, developers need some kind of an engine, a platform, APIs that they can call, that will bind together these remote services and local services. We call this the Web Services Platform. The Web Services Platform communicates with the remote services using XML, specifically technologies such as SOAP. The method of communication between the services and the local application is message-oriented rather than being, for example, in a remote procedure call, an RPC. The message-oriented way of building applications enables you to scale better. The messages are self-describing, so you get better interoperability across different types of applications. Fundamentally, this way of building applications is about enabling you to choose the infrastructure you want to use, whether it's Corba or Java or DCOM, Microsoft COM, and to integrate them together easily. We believe we're building the best platform for doing this, and we're absolutely willing to go head-to-head with the competition and to beat them on implementation. On the next slide, you'll see an overview of the SOAP family. Many of you have probably heard about SOAP in the computer trade press. It's garnered a lot of interest. Most recently, it garnered interest when we submitted it to the W3C for standardization. Although that's not that notable, what was notable was the lineup of people we had who were co-authoring and co-submitting with us. Originally, SOAP was developed inside Microsoft with the involvement of Developmentor and Userland Software. Developmentor, many of you may know, is where Don Box works. When we revved SOAP to version 1.1 a few weeks ago, IBM came on as a co-author. IBM is now baking SOAP into WebSphere, MQ Series, and many of its other products, just as we are baking it into our Windows DNA products, Exchange, SQL Server, Visual Studio, and even COM. What is SOAP, though? Why is it garnering so much interest? Put simply, SOAP is a generalized messaging format based on XML. I've been talking for about 3 hours already today. It provides a set of rules for how you can format XML to exchange data among different types of systems. If you look at, for example, Section 5 of the SOAP specification, it's a common type system that can be used across object models, operating systems, and programming languages. SOAP provides the low-level wire format connectivity between two endpoints. We've demonstrated interoperability between Corba applications, Java applications, Linux applications written in Perl, and Windows applications. And in fact, the swapping out of different applications for each other using SOAP. One of the great advantages of SOAP is that unlike, say, Corba, DCOM, or Java, it's designed for heterogeneous environments. It does not require you to have the same software infrastructure at both ends. If you have Corba at one end, you have to have Corba at the other end. You have to have the whole stack. And in fact, you may have to have the same vendor's implementation at the remote end. The same is true of Java, and to some extent, the same is true of DCOM. We're not without problems here. But the world is fundamentally a heterogeneous place, and getting more so. SOAP enables us to create interoperability among these different heterogeneous environments very easily. Most of you who are familiar with building object-oriented applications realize that the wire format is not enough. The wire format of DCOM is fundamentally uninteresting, for example. You need more. You need a way of describing applications, and you need a way of finding them on the web. We're providing ways of doing both of those also. In particular, the Service Description Language, or SDL, is another XML grammar that enables developers to easily describe the messages that a service will receive and the messages it will send in response. This is different from IDL. IDL describes how the implementation is actually built. It describes the interfaces, methods, and classes. SDL exists at a higher level of abstraction, dealing with the concept of a message. And in fact, a message can be a very complex document that follows the rules of, for example, an XML schema. SDL is designed to be readable by humans, but primarily to be used from within tools to give developers APIs that they can program against. Sitting above that in the value stack is what we call DISCO, the discovery specification. We haven't talked a lot about this publicly, but it's basically a set of heuristics for locating a service description file. It's primarily targeted at being used from tools, and also primarily targeted at using HTTP to actually locate the files. We haven't released that to the public yet. When we do, we assume that it will have many more features in it to enable you to discover features, the capabilities of a service using other protocols. Each of these layers is already being extended in many ways. The BizTalk and MSMQ teams, for example, are working on extending SOAP to provide reliable message delivery. BizTalk framework, even today, is SOAP compliant. It provides a set of routing and manifest extensions to the header portion of SOAP. And it provides a different body format that is much more useful for business document routing. SOAP is primarily targeted at being able to serialize arbitrary object graphs, whereas BizTalk is designed to pass around business documents like purchase orders and invoices. SDL similarly is already undergoing extensions to provide for orchestration and choreography. Many of you who were at TechEd or saw the TechEd keynote saw Dave Washaw talk about BizTalk workflow. That's an extended set of capabilities that layers on top of SDL and doesn't just describe the messages that a single service will send and receive. It describes the choreography of multiple services and how they will interact. We're also already beginning to think about how we extend discovery. For example, it's not just useful for you to be able to go to a site and find out the capabilities of that website's services. You need to have repositories that contain all of the services that you can access. It's kind of the equivalent of, say, componentsource.com today, which provides a repository of COM components. You also need ways of searching across different services to find out what's available and where they are. We're working on all of those with the usual list of partners that you would expect. On the next slide, you'll see that we have already begun to deliver on this. At TechEd, we announced the SOAP Toolkit for Visual Studio 6.0. The SOAP Toolkit is a set of client and server-side components that extend Visual Studio 6 to start bringing it into this world to enable developers to expose and consume web services using SOAP and SDL. On the server, it includes a wizard that can take an existing COM component, search through its type lib, and from that extract an SDL document. On the client side, it includes a plugin to Visual Studio 6 called ROPE, the Remote Object Proxy Engine. When you point ROPE at an SDL file, it instantiates a programmable proxy that gives the developer a set of APIs that they can write against, in whatever language they want, by the way. Once the application is actually run, ROPE is then responsible for serializing those method calls into SOAP requests that go out over the wire back to another component we provide in the toolkit, the HTTP listener. The HTTP listener is then wired back to the original application. On the next slide, you'll see that this is just a beginning. We fundamentally need more. You need a way of doing activation and deployment and security, reliable messaging, things like that. What we're fundamentally talking about here is turning COM into a web component model. On the next slide, you'll begin to see how we're doing that. We call this the Web Services Platform. As I mentioned, this is going to be announced at a very high level at Forum 2000. The detail I will give you today is much finer grained than what you'll be hearing there. And I'd just like to remind you that until the PDC, which I encourage you all to attend, we're not going to be public on this information. But once we hit the PDC, all the details of how this works and what it's going to do will be disclosed. At the very top level of the Web Services Platform, we have an advancement to active server pages. We call it ASP+. That is the web programming model that we're going to be talking about. ASP+ is built on top of what we call the Services Framework. The Services Framework provides the common APIs and services that a developer needs to program against. All of the execution of the code is actually managed by a common language runtime. Runtime is responsible for maintaining the security, doing the deployment, process separation, stuff like that. I'll drill into each one of these in more detail. On the next slide, you'll see the common language runtime called out. Common language runtime is responsible for managing the running code. It does threading and memory management. It satisfies the dependencies that components have on each other. More deeply inside it, it provides a very fine-grained security system that goes well beyond anything that you can get today in terms of the amount of evidence it's able to gather and the granularity of the decisions it's able to provide back to a component that's asking for capabilities from the system. This entire environment is designed to be running with multiple programming languages. So far, we have more than 20 programming languages running on top of this. The runtime is also responsible for managing the deployment of applications. We call everything that it does no-touch deployment. At a deep level, basically what this means is that when you install an application on a system, it is not going to affect any other running application. On the next slide, you'll see some of the obvious benefits of this. Developers aren't going to have to worry about memory management, reference counting, or even implementing things like query interface. Much of the COM infrastructure that was formerly necessary to turn an application into a COM component is now handled automatically by the runtime. This results in a dramatic reduction in the number of lines of code you have to write. The fewer lines of code you have to write and the less memory management you have to do by yourself, the fewer bugs you're likely to have in your code. The security model is responsible for making sure that rogue applications can't come down to your system and do things that you don't want them to do. I'll talk more about that in a couple of slides. The deployment subsystem makes deployment as easy as copying applications onto a system. There's no more registry touches. There's no more DLL hell. And one of the primary benefits of having a runtime actually execute your running code is that the runtime is able to make intelligent decisions about what resources the applications should be allocated. The result is improvements in scalability, performance, and the reliability of applications. No-touch deployment. Today, as you know, when you build an application and you deploy it on a system, you may involve touching the registry in 20 or 30 places, installing DLLs on the system, finding out that DLLs you needed are actually versioned incorrectly, problems like that. The runtime is responsible for actually managing deployment of applications now. It does this in cooperation with the tools. When the developer builds an application, we package it in something called an assembly. The assembly is the fundamental unit of deployment on the runtime. Assemblies are self-describing. They include metadata. At one point, it was XML metadata. We've transitioned it back to something else temporarily. Ultimately, it'll be XML metadata again, using the SDL format. The metadata is dynamically generated by the tool based on the interfaces you want to expose. This metadata also includes the dependencies that the application has. It includes information about what versions of the compilers and the components it was built with, what versions it can run with, greater than this version, less than this version to this version, that type of information. It's up to the runtime to actually satisfy those deployment requirements. It can do this by leveraging the security system and, in fact, going out and retrieving applications that are components that need to be installed on the system. As you can imagine, if you have multiple different assemblies that are requesting different versions of the same DLL, you may wind up with what we call DLL hell today. Well, the runtime is also responsible for process isolation and memory management. Consequently, we can actually have side-by-side operation of different versions of the same DLL on the same system. In other words, two versions of the same DLL can be called and instantiated and used simultaneously, even if they have the same name. It goes beyond that, though. If you actually have an assembly that has components that itself call two versions of the same DLL, so for example, two different versions of something in MDAC, we can actually manage those separately as well. The runtime will keep them separate from each other. They can't hose each other. That's a pretty major advancement. In addition to the obvious removal of registration and the other overhead of just deploying an application. The result now is that applications can be deployed simply by copying them onto your system, and they can be uninstalled just by deleting them. There's no more stuff left in the registry unless you want it to be there. You can still use the registry if you want. Code access security, the security system in the runtime, as you'll see on the next slide, is extremely important to enabling this type of deployment. Clearly, if the runtime is going to be going out and dynamically fetching components, it needs a way of ensuring that those new components aren't going to step on other components. The code access security model within the common language runtime is responsible for method-level security. It is responsible for gathering evidence of where the application was downloaded from, where it was installed from, who wrote it, whether it's signed with an authenticode signature or not, what methods it's trying to call, and in fact, we can cascade down the tree and see what methods all of its dependencies are going to call as well. That information is combined with administratively set permissions and the policy on the system. The result then is that the runtime will basically, when the application comes down and requests a set of permissions, the runtime will then come back to it and say, you know what, you're fine to run. Alternately, it can say, you're fine to run, except you've said that you want to install a file in c:\winnt, and we can't allow that. What's interesting about this model is that the developer building the application can actually mark certain permissions as being optional. So if they ask for the ability to write to c:\winnt, and the runtime doesn't grant it, they can actually have a fallback position. In other words, there's a graceful degradation. It's not just on or off security. It's very fine-grained. On the next slide, you'll see a list of some of the languages that we support on top of this runtime. Most interesting, yesterday I saw a demonstration of an active server page written in COBOL. The obvious question on this slide is, what about Java? It doesn't appear on this slide. Java, as a programming language, is something that technically could be hosted on top of the runtime. As you know, though, we're involved in a lawsuit with Sun Microsystems that makes it very difficult to talk about the future of Java at this company. And to some extent, Sun's actions with relation to us kind of touch upon what the future of Java is in the industry. Already, we're starting to see the reality set in about Java's limitations. And developers are starting to realize that, yeah, it's a useful tool, but it's not the only tool. At a top level, we believe that the concepts represented by the web services platform, concepts of interoperability, are far more important than achieving a homogeneous infrastructure using Java. And of course, Objective-Camel is going to be the key language for Microsoft going forward because it gets you over that development hump. I had to say it. On the next slide, you'll start to see what actually touches the developer. We call this the services framework. Today, when you build an application using Microsoft Visual C++, you're programming against MFC. When you use J++, you're using WFC. When you use Visual Basic, you're using that framework. For developers that flop from language to language, this is a huge problem. Even for development houses that are trying to build applications using multiple different languages, perhaps drawing on the resources they have available, it's still a problem. The services framework provides a unified framework, bringing together all the capabilities in MFC, WFC, and the Visual Basic framework together. So we provide all of that richness that they provide. We provide it to any programming language in the same way. This entire framework has now been rationalized. It's object-oriented and consistent across itself. It's hierarchical. It's also extensible. If you find that we haven't implemented a function that you need, as an ISV, for example, we provide a clean way of delineating where you're going to sit in the namespace hierarchy, rather than just installing a new version of a DLL that you've modified. The framework is, of course, secure and leverages all the security aspects of the runtime so that components of it can be downloaded to a system dynamically. Why is this a good thing? Well, having a common framework enables things like cross-language inheritance, interoperability, error handling, and one more I'm forgetting right now. Oh, debugging. The result is that I can build an application in COBOL, inherit from it in C++, inherit from that in Visual Basic. The framework also manifests this same capability. It doesn't matter what language the framework is written in. If you want to take something in the framework and inherit from it and create a new expanded version of that framework, we enable you to do that. This framework is designed to integrate deeply into the tools. Often you'll hear the Visual Studio team talk about features like WinForms or Web Forms or ADO+. Well, these are actually capabilities that are in the framework, not in the tool. They're therefore available to any programming language. WinForms, for example, provides a rich GUI environment that's layered on top of this framework. ADO+ is our next generation data access stuff that you'll hear about later today. The web form stuff is a feature of ASP+. But the interesting thing is that the framework is providing these capabilities. So that if a third-party tools vendor wants to come along, or an ISV, or even a corporate that's using Notepad for development, they'll get the benefits of all of these capabilities that are in the framework. You don't need our tools to do it. That said, the framework integrates incredibly well with the tools. You go beyond just writing code to the drag-and-drop experience that you expect from Visual Basic, only you get it in C++, Visual Basic, C#, a new programming language we'll be telling you about today. And in fact, anybody who integrates into the Visual Studio 7 shell through the VSIP, for example, Perl and Python are both doing that, will have the same style of drag-and-drop access to this framework. This is an incredibly powerful message for sites that are having to wrangle with, what do I do with my COBOL developers? Do you realize that COBOL is actually the second most widely used language after Visual Basic? There are a lot of people out there in that environment who are going to love to be able to move to this without having to be retrained. At the higher level of programming, we have this thing called Active Server Pages Plus. Active Server Pages Plus layers on top of the services framework and enables the web application and web service programming model very, very easily. If you're familiar with ASP today, basically the code you look at is a mixture in a page of script code and HTML that is interpreted the first time you go through it and then cached. The result is that we have spaghetti code. Now that said, there are about 1 million people building ASPs today. It's incredibly powerful and incredibly easy to do. There's some limitations to it, though. In particular, it's not very tools-friendly because it's spaghetti code. The performance isn't all it could be because it's fundamentally based on an interpreted script-based model. Also, you have to write an awful lot of code to do fairly mundane things like session state management. Active Server Pages Plus leverages all the capabilities of the runtime and the services framework and addresses those areas. We've introduced a couple of concepts that are a little bit new. In particular, ASP Plus Web Forms are server-based user interface controls. Much like you have ActiveX controls today that you drag into Visual Basic, these server-based controls are responsible for emitting user interface in HTML. Yet when you talk to them when they're instantiated on the server, they provide a programmable, object-oriented infrastructure. The result is that a developer can tag all of the standard HTML tags, like text boxes and drop-downs, as run@server. And immediately, they get access to a programmable version of that same UI widget. In addition, the ASP Plus infrastructure is the thing that's responsible for managing session state, user state, file logging, stuff like that. And all of these controls leverage that and pick up on it from the start. The new version of ASP Plus is also a multi-language environment. As I mentioned before, I just saw yesterday an ASP page written in COBOL. Well, it called on these server-side components. And in fact, it called on components written in COBOL as well as written in C#. So the multi-language integration is happening there. By factoring this user interface, by factoring ASP into a more component-based architecture, we're now able to compile it in a way we haven't been before, with the obvious performance gains that that gives you. We're also able to layer intelligent tools on top of it. So you can build ASP Plus pages from within Visual Studio now. You no longer need Visual InterDev. You have full access to the full Visual Basic programming language, C#, C++ with managed extensions, and any of the other languages that choose to integrate into this. For example, COBOL is doing it, Perl is doing it, Python is doing it. I think Smalltalk is doing it as well. The result is you're going to see a proliferation of different programming languages being hosted from within active server pages. Another important point about the web forms controls is that they generate scalable user interface. They automatically detect the client that's coming into them and will give back the appropriate user UI. So, for example, if you come in with a down-level browser, an early version of Netscape, for example, they'll give you back straight HTML 3.2. If you come in with IE 5.5, they give you dynamic HTML. Some of the controls have actually been extended so that if you go into them with a WAP-enabled cell phone, you actually get WAP back. And others have been extended at the high end so that if you go into them with a rich Windows client, you can actually get downloaded WinForms controls to your system. The capability there, then, the advanced capabilities include things like alpha blending and some of the rich UI stuff that you've grown to expect, like overlapping menus and easy right-click pop-up menus and stuff like that. Obviously, Active Server Pages Plus leverages all the deployment stuff we've built into the runtime. You can now install ASP-based applications on a system just by copying them up to the server. And in fact, you can copy over running applications. Today, when you try to do that, you'll find that the files are actually locked because they're in use. Well, ASP Plus gets rid of that. And when you copy the new code up, what will happen is ASP Plus is responsible for spitting down any requests that are coming into the existing application and redirecting all new requests to the new version of the application. Perhaps most importantly, this current programming model is compatible with today's ASP. You can still continue to write code the same way you have. We're providing a very graceful transition path from today's ASP to ASP+. On the next slide, you'll see some of the benefits of taking this approach. Performance increases dramatically, 2 to 3 times, in fact, just by moving ASP code over to ASP+ and making the minor syntactic changes you have to do in order to change from BB script to VB. In addition, there's a dramatic reduction in the number of lines of code you have to write. On one sample B2C application that we built internally, it was 500 lines of ASP code, a little bit more of that in JSP, and it was about 30 lines in ASP+. The reduction was a result of the fact that ASP+ dynamically and automatically handled the session state, and in addition, the controls basically reduced the number of lines of UI wizardry that you had to write. I've already touched on the deployment issue. One of the fundamental tenets, though, of ASP+ is about operations. It's about maintaining 100% perceived uptime. We've taken a lesson from Apache. And when ASP applications die, for example, we can sense it. Well, actually, we've taken a lesson from Apache, and we can actually kill running applications and restart them periodically to make sure that they aren't getting out of hand. We can do that based on the number of requests they've gotten or how long they've been running. But we've gone beyond that. The ASP+ infrastructure can actually sense when an application is starting to behave erratically, kill it, and restart it. Scalability is also a big point of ASP+. Today, ASP is difficult to scale out across multiple systems. Well, by building this loosely coupled session state management into ASP+, we've actually made it so that we don't have to maintain session state anywhere. And in fact, we've made it extremely easy for you to pass session state transparently in hidden fields around applications. This means that you can throw just more and more web servers at a problem, and the more users you have, and the pages will automatically scale across them. For state that does in fact need to be maintained somewhere, we provide a very rich set of services for persisting it to databases, XML, flat files, a bunch of other different ways. On the next slide, you'll see us talk a little bit about ASP Plus Web Services. This is the other major feature of Active Server Pages Plus. Instead of what web forms do, which is emit UI, the web services emit SOAP. It uses all of the same ASP Plus infrastructure. But instead of sending out UI, it sends out SOAP. The ASP Plus infrastructure for web services is also responsible for dynamically generating SDL. So the developer only has to write a very simple amount of code, mark methods as being web public. ASP Plus will be responsible for dynamically generating the SDL from that, and also dynamically generating the SOAP from that. The developer doesn't have to know anything about SOAP or SDL. They just write what they want to write, how they want to write it, in whatever language they want to write. There's another feature of ASP Plus that's really interesting. We call it the personal tier. It enables you to basically take entire Active Server Pages applications offline, take them with you. Obvious advantages to this are, if you're familiar with using, MS Market or MS Expense, if you wanted to take those capabilities offline, take them with you on an airplane, do your expense reports, come back and resynchronize, we can do that now very easily. But there are more interesting capabilities even when you start to combine the capability of writing Active Server Pages that run locally with Active Server Pages that run remotely. You can actually see performance benefits that you can get from having local and remote stuff working together. And the developer only has to learn one programming model. Obviously, this also, because we're now installing code locally on the system, has to leverage the runtime security. So in conclusion, basically, we're committed to delivering software as a service as a company. We are making fundamental advances in our object model plumbing, our tools, Active Server Pages, to make that incredibly easy to do. We're going to make it not just easy to build them, but easy to deploy them and easy to make sure they stay running. And that's what the Web Services Platform is all about. In addition to this, since I have a little bit of time left, I'd like to show you a couple of demos of Active Server Pages Plus. So let me start with showing you a very simple form. On this form, you will see a text box, a drop-down, and a button. When I click on Lookup, it doesn't really do anything. In fact, my system is hanging. And in fact, IE is entirely hung. Let me show you the code that's behind that lovely page. All of you who've given demos before, there we go, just came back. The code behind this page is pretty standard HTML code. There's nothing special about it at all. Now, let's say that I wanted to use Active Server Pages Plus and just do standard ASP-style development. So what I'm going to do is just replace that page with a page that adds a very simple script right here. Just going to iterate from 0 to 7 and increase the font size of a simple page. So I will reload this page. Now I'll really reload the page. The demo is just completely horked. Oh, didn't save the file, that's why. There we go. Control S, the best feature in Notepad. So the page is actually compiling right now on the server. You see the result. So that's standard style scripting within an Active Server Pages Plus page. So we keep what you got today. Now, to show the multi-language capabilities, let me just grab a snippet of code from here and tuck it into there. Save it. So now the actual syntax I'm using in the script is C#. And all I had to do basically was write it in C# and say at the beginning, page language is C#. Okay, that's not really very interesting. Let's get to the more interesting part.
John,
yes?
Can you just halt on a page for just a second for the resolution to resolve each time you go somewhere?
Sure. So I've been asked to halt on a page so the resolution will resolve. So what I'm going to do here is show you some of the run at equals server capabilities. So let me just select everything. What I'm doing here is I am tagging this form as a run at equals server, the text box as run at equals server, the drop down and list items as run at equals server, and the button as a run at equals server. The result of this is going to be instantiating of these web forms controls on the server. So now when I reload the page, and it recompiles. The big difference here is that previously what you would have seen if I had done this, and I do a lookup, and the page recompiles again. I am in demo hell, aren't I? I think IE55 just, there we go. So I do a lookup, it does a post back to the server, and it's maintaining my state automatically. So basically post back, that works just fine. Moving along, I'm going to add one of the rich web controls that we include with ASP Plus to the page. This particular one is an add rotator. So I'm calling the add rotator control. It's loading a few ads, and I'm going to run it on the server. So when I reload the page now, and it recompiles it, now I have rotating ads, and I still have the same capability to do session state maintained automatically, although IE is hanging again. I'm going to have to raid that. Oh, that's coming back. Move on to the next portion. Let's actually show what you can do with the server controls and how they program together. So what I'm going to do in this one is, in my C# scripting language, I'm going to script these controls together. So basically grabbing text fields out of them and showing the capabilities that they have together. All right, so when I say my name's John and I select serial, hi John, you selected serial. The actual code to write that is extremely simple. What I did was I hooked an event down here, submit button click, up here, submit button click. And I basically said that when you catch that event, just print hi, grab the name.text out of the name box down here, and then say what I selected from the category dropdown. Very simple. Let me go back and show you kind of the last touch of this, which is to show you how to build a custom server control. ASP Plus is extensible, so you don't have to rely on just the controls we give you. And what I'm going to do here is incorporate a calendar control that was actually written by one of our program managers on an airplane one day that brings together some of the other stuff that we just saw. And let me recompile it here, show you what it looks like. So the page now basically says, hi, let's change my name to Bob. And I'm going to select serial on the 17th. So what it's going to do, eventually, this must be because I don't have my network card in. There we go. I selected soda on tomorrow. What we actually did here was just hooked the mycal.date from there and just appended it. So that's all well and good, but not horribly interesting. Let me show you something else. This is actually a web service. This is an earlier build, so ignore this. The source code for this is something I wrote a little while ago. It's very simple. Basically, I'm just adding some numbers here, I'm subtracting them here, I'm multiplying them, and I'm dividing them. I declared all of these as being web methods, so they're going to be public to the world. Now, when I go into my little math service here to show you that I can just dynamically generate the SDL, we'll pull up some SDL. It's going out to the service, compiling it, and the result should be a dynamically generated service description. One hopes. So this is what SDL looks like. As you can see, for example, on the add method that I marked as being public, takes two inputs, and its response is going to be an integer. So it's strongly typed. So now I can actually just use my web browser here, actually, to talk to this service using HTTP GET. It's a lot simpler than using SOAP, and it demos well. I would say add a equals, well, I might as well pick some new numbers.
Increase the font of that code there.
This code here?
Yeah, that. Pop everything up.
There we go. So if I add two numbers, a equals 34 and b equals 2, and it goes out and touches the page. Oh, I should really have some talking points to go over what's going on right now, but pretty much it's going to add two numbers and return 36 as an integer. Let's use the divide service. Let's just divide these two numbers because they happen to not divide evenly. So the way I've implemented divide here, I'm dividing 8,593 by 883, and this is telling me that the result is 9, which is actually not right because I didn't pick two numbers that go into each other evenly. So what I'm actually going to do here is go back to the original source code file, and I'm going to change my ints to floats. And I'm going to rerun the same query. It's going to go out, it's going to recompile it, and now you'll see dynamically it's done the right thing. And if I go back and ask for my SDL again, it will actually, ASP Plus will dynamically modify that SDL. Oh, man. There we go. And when I go down to divide, it'll tell me that I'm going to get back a float. That's kind of a high-level view of ASP Plus, the services framework, and the common language runtime. And at this point, I will open it to questions.
Okay. 1 second here. Okay, first question is, how is the application assembly product differentiated from the Microsoft installer? If you could repeat the question.
The application assembly, how is the application assembly different from Microsoft Installer, MSI? Actually, they're complementary technologies. You can use, assemblies are something that's generated by the tool automatically. It basically represents it's kind of an application. It's not quite, it's a little bit different kind of theoretically, but think of it as an application. And the metadata that wraps that application and tells all of the dependencies that are within that application. Because in this new environment, we don't necessarily have to put anything in the Windows registry, and we don't necessarily have to deal with some of the DLL conflicts that you have to deal with on today's Windows. You actually, for simple applications, don't need MSI within the web services platform. That said, The way the web services platform does things like transitions or COM+ partitioning and those other COM+ services that you've grown to know and love, those are outside the boundary of code that's managed by the common language runtime. It's called unmanaged code. When managed code and unmanaged code interoperate and want to talk to each other, we still need to put things in the registry so that the unmanaged code will actually know where it is and how to talk to it. For applications like that, you're definitely still going to need to use MSI. Also, assemblies are basically they're just a chunk of data. Think of them as like a DLL, or maybe a collection of DLLs. There's no actual information that's contained in the assembly that says, where do I install these files? So even within a managed environment, if you wanted to build an installer application, you will need installer applications so that you just don't wind up with files randomly scattered all over your system. So, like I said, they're complementary technologies.
Okay, next question. This is one you would expect. When do you think Visual Studio 7 will RTM?
So the question is, when do I think Visual Studio 7 will RTM? I want to make a couple of points here. The web services platform is technically separate from Visual Studio 7. They're separate products that are both headed up under the same division. They are moving on the same timetable, so they will go through their releases at the same time. We expect, at the PDC, we will definitely be giving out bits. They will be PDC technology preview bits. We will go into beta later this year. We will ship the product when our customers tell us it's ready to ship. Realistically, that's next year sometime. As many of you are probably aware, Microsoft is not always super accurate in its predictions about when we'll ship products. So I will just say, I think it'll be sometime next year.
Okay, great. Next question. Will the timing of the release of ASP Plus coincide with the release of Visual Studio 7?
So the question is, will the timing of ASP Plus coincide with the timing of Visual Studio 7? The answer is that relates back to the previous one. The web services platform and Visual Studio 7 right now are on synchronized ship schedules. ASP Plus is a feature of the web services platform. It can't exist independently of the web services platform. And in fact, the reality is it's best leveraged from within Visual Studio 7. Therefore, the current plan is that we will ship Visual Studio 7, ASP Plus, the web services platform, together at the same time.
Okay. Next question. Well, I think we're about done here. You might want to, again, reiterate the NDA issues.
Right. So timing on this. We will announce this stuff at a very high level at Forum 2000. We'll talk about ASP Plus, the services framework, common language runtime. We'll give out the names and not much more. We won't explain any of the detail really I've given you today. This information won't come out until the PDC, July 11 to 14. For those of you who aren't planning to attend, I really strongly suggest you do and you change your plans. And also tell the folks you're working with that they should be at the PDC. It's going to be a super important event. This is the way applications are going to be built at Microsoft for a long time.
And last thing is perhaps just mention that at 11:15 we'll give a Visual Studio 7 overview by Dan.
Okay, that's a good point. At 11:15 today, we will be giving an overview of Visual Studio 7. Dan Hay will be giving that. And throughout the rest of the day, obviously, we'll have other sessions on C# and advances to VB. All right, thank you very much.